Okay, area and arc length of a circle. So, uh, and actually we want, instead of circle, that should be sector. And so here's my sector right here. So I'll outline it in blue. Okay. And so it's just part of the circle that we're dealing with. And so we have this angle here. I'm going to call the angle theta, but it could be 50 degrees. In fact, we'll maybe start with a number so that it makes sense to you. 50 degrees. And let's say we know the radius of this circle is, maybe 100 feet. Okay, so we can calculate the area of the sector and also the arc length. Arc length would be the distance from here to here on the circle, the distance around the outside of that circle. So the distance around the outside of a circle, you've learned up to this point, is 2 pi times the radius. 2 pi times the radius is the entire circle, but we just want part of the circle. Well, an entire circle, if you go all the way around a circle, the whole thing is 360 degrees. So we're just going to deal with 50 degrees out of 360 degrees. So just that part of the circle. And then all you do is take that proportion of the circle times your formula, 2 pi r. In our case, r is 100 feet. And so then you just get out and calculate that. So 50 divided by 360 times 2 times 100, and then times pi. So we have 27 and 1/9 or 7/9 pi, or approximately equal to 87.3. Yeah, I can't write 87 down, 87.3. So that's the arc length. So for area, you just do a similar thing. You take, we know the area of a circle is pi r squared, and the arc, or the area of that particular circle, so if we just want the area part of it, so this part here, you do the same thing. You take 50 over 360 times pi r squared. And r, in our case, was 100. And so you just do the same thing. And we got to square it. So it'd be 100 squared if you do order of operation times 50 divided by 360 is 1,388 and 8/9. So 1,388 and 8/9 pi. Take that times pi. And that would be 4363.3. Okay, so now we got to worry about one other part, and that's if your central angle is not given to you in degrees. So let's say you have a sector here, and we'll call it theta again. But it's not in degrees, it's in radians instead of degrees. So maybe we'll use a capital R. Whoa, whoops. Excuse me there. Let me undo that. So, so that angle, let's say it was 2 pi over 3 for radians. So radians are typically in terms of pi. Actually, doing arc length and area ends up being a lot quicker in radians because it's eliminating your pi's and things like that. So let's look at it if it's a variable, and then we'll look at the example with pi r, 2 pi over 3. So let's just say we had just any old sector, and let's call this capital R, and this is little r for the length of the line, your radius. Okay, if you go back to the other one, we know the circumference of a circle is 2 pi r. If we would just have part of the circle, we always do your angle divided by 2 pi, because 2 pi is 360. 2 pi and 360 are the same, times pi times r. And what happens is you end up with your angle in radians divided by 2 times your radius. because those cross out. Oh, and I also forgot the 2 there. So the 2 would also cross out. Screwed that up. So you don't have that either. So it's just your angle in radians times your radius. But the angle has to be in radians. So if we go back to this example with 2 pi over 3, we could look at that. It would just be 2 pi over 3 times your radius and whatever. So what's a radius? What radius did you have?
6.
6. So 2 pi over 3 times 6. These reduce, that's 2. And that's, oh, sorry, that's 2 and that's 1. Wow. So 4 pi is your arc length. So if you take 4 times 3.14, you get this distance. So 12 or 13, somewhere in there is the length. Now for area, it's very similar. So if you look at it just as a formula, again, it would be your angle, central angle in radians divided by 2 pi for which part of the circle. 2 pi is the whole circle. R is the part of the circle we're dealing with. Times pi r squared. And what happens is your pi's cancel. And so now the formula for area of a sector is your angle in radians divided by 2 times radius squared. So in our example problem, our radius is 6. So it would be 2 pi over 3 times 6 divided by 2 times 6 squared. And so you simplify that, 2 pi over 3 divided by 2 over 1, that's a complex fraction. So that would be 2 pi over 3, you flip and multiply, times 1 over 2, times 36 for 6 squared. And 2's cancel, 36 and 3 cancels to 1 and 12, and so we end up with 12 pi. So the area of that sector is 12 pi. And that's how you do both arc degrees and in radians with a few minor errors. Not my best video, but I hope it helps.